Hey guys, today I'm going to be doing a Leetcode question called Meeting Rooms 2. It's a medium level question. It's pretty straightforward if you know the trick, and it's been a pretty popular question among the bigger tech companies, so it'd be kind of interesting to do it. So given an array of meeting time intervals consisting of start and end times, so we have an object called interval that has a start and end. Basically find the minimum amount of conference rooms required. So in this example, 0 and 30, 5, 10, 15, 20. 0 and 30 is going to need its own conference room because this end time is greater than the other ones. Basically the logic is if this previous end is less than the next start, that means you'd only need one conference room here. So the answer there should be, since this end time is greater than this start time, we know that this needs its own conference room, and then we can share one conference room for these. Therefore, you'd need two. Cool. So that's kind of the logic of it. There's some other generic stuff we need to do. So let's code it up. So if intervals equals null, or intervals dot length equals 0, return 0. It's pretty self-explanatory. All right. Okay, so let's think here. What we need to do is we need to sort this object based on its start, and then we can use a priority queue to manage the min values. So let's do that. So arrays.sort of intervals, and then we need a new interval comparator, which we will implement right now. So private class interval comparator implements comparator of interval. So we're going to override the compare method. Compare interval A, interval B. Alright, so A.start minus B.start. We're going to sort it based on the start values from min to max. So next thing I want to do next thing I want to do is create a priority queue or a min heap. So basically this is going to keep spitting out the min value, which is going to be pretty important when we're looping through this. So then we can add intervals at 0 end. So like I said earlier, it's really important to compare with the end with the start. So this is what it would look like in sorted order because it's basing it off the start value. So 0, 5, 15. So let's loop through it for I equals 1, I is less than intervals.length, I plus plus. Alright, we're starting at 1 because we just want to start from there. So let's do interval cur is equal to intervals at I. Now if cur dot start is greater than pq dot peak, so if current dot start, which is 5, if it's greater than pq dot peak, so that means we'd only need one conference room between the two. So it's like merge intervals. It's like similar to the merge intervals Leetcode question. So then we can just pop it off the queue. And then we're going to want to add the current cur.end. So that way the priority queue will now hold on to the next value. So after this, all we'd have to do is return pq.size. Actually, if current.start is greater than pq.peak, now what if they're equal, right? So we would still want to remove it because technically you can start a new conference room, a new meeting right as soon as the other meeting ended. At least in this world. I don't know about the real world. That probably wouldn't work. But in the context of the question, it should work. So basically, let's run through it. So all right, so let's do this. So PQ So PQ right now has intervals at 0.n, so it's 30. So interval current is equal to intervals at I. If current.start, which is 5, is greater than or equal to PQ.peak, which is 30, it's not. So PQ is now going to add current.end, which is 10. And since it's a priority queue, it's going to percolate, and 10 will not be at the top. All right. So we go to the next one, 15 and 20. So if current.start 15 is greater than PQ.peak, which is 10, which it is, PQ.remove. So we'll remove this, and then we'll add the current.end, which is 20. And then we'll return the size, which is 2. So that should work, actually. Let's try it out. I mean, I hope it works. I always say that, and then it ends up never working. So maybe I should stop saying that. Oh, wow. All right, it actually worked. Wow, it's a shocker. So basically, the key here is to use this comparator to sort the object based on the way you want it. Because of that, it's O of n log n solution. It's better than a O of n squared solution where you just compare everything. Yeah, and then a priority queue to basically keep spitting out the min value, so you can keep comparing the min value to the end. Yeah. Well, I hope that was somewhat bearable and enjoyable. Yeah. Thank you, and I hope you enjoyed it.